Recently, the Japan Maritime Self-Defense Force accomplished what the United States Navy couldn't. From the deck of the experimental vessel JS Asuka, Japanese engineers successfully fired a ship-mounted electromagnetic railgun at a moving target vessel and scored a direct hit. While America abandoned its railgun dreams in 2021, citing technical challenges and budget constraints, Japan methodically solved every problem and is now poised to deploy the world's first combat-ready electromagnetic weapon. How did Japanese engineers succeed? What makes this railgun so terrifying that it could end naval battles in seconds? Join us as we explore how Japan's new railgun has achieved what seemed impossible, and why this electromagnetic weapon is transforming naval warfare forever. The physics behind railguns is quite simple. Imagine taking an electric motor and flattening it out so instead of spinning an armature in circles, the electromagnetic force shoots it in a straight line across the room. That's essentially what a railgun does. Two parallel conductive rails connected to a massive power source create a circuit with a conductive projectile positioned between them. When tremendous electrical current flows through this circuit, it generates an intense magnetic field. The interaction between this field and the current creates the Lorentz force, the same principle behind maglev trains and electromagnetic catapults on aircraft carriers. This force accelerates the projectile along the rails to velocities that conventional gunpowder could never achieve, launching it at hypersonic speeds without any chemical propellant. The advantages over traditional guns are profound. Conventional naval artillery relies on controlled explosions of gunpowder or other chemical propellants to generate the pressure that drives projectiles down the barrel. This creates fundamental limitations on muzzle velocity because there's only so much energy you can extract from chemical reactions before the barrel literally explodes from excessive pressure. Chemical propellants also mean ships must carry tons of highly flammable, explosive ammunition that becomes a catastrophic vulnerability if hit by enemy fire. Magazine explosions have sunk countless warships throughout history, from the HMS Hood destroyed by the Bismarck in World War II to more recent incidents. Railguns eliminate this vulnerability entirely because the projectiles are inert metal slugs with no explosives whatsoever. A ship could carry thousands of rounds in perfect safety, and even if enemy fire penetrated the magazine, nothing would detonate. The cost economics is equally revolutionary. Modern anti-ship missiles cost $1 to $3 million each, while advanced interceptor missiles for shooting down incoming threats run even higher. A railgun projectile is essentially a shaped piece of metal, potentially costing as little as tens of thousands of dollars, depending on sophistication. When you're defending against saturation attacks where adversaries launch dozens or hundreds of cheap drones and missiles to overwhelm your defenses, the economic equation becomes critical. Traditional missile defense systems bankrupt themselves trying to shoot down swarms of inexpensive threats, spending millions of dollars on million-dollar interceptors to take down $1,000 drones. Railguns invert this equation completely, allowing defenders to engage unlimited targets at minimal cost per shot. Japan's journey to railgun success began in the mid-2010s when the Acquisition, Technology, and Logistics Agency, or ATLA, launched foundational research into electromagnetic projectile acceleration. The Ground Systems Research Center initially experimented with a tiny 16mm prototype, learning basic principles before scaling up. By 2016, the government committed to full-scale development of a 40mm railgun system, establishing ambitious performance targets, achieve muzzle velocities of 2,000 meters per second, and demonstrate barrel durability of at least 120 rounds. These targets address the two critical challenges that have plagued railgun development worldwide. First, you need tremendous velocity to make the weapon militarily useful, faster than anything chemical propellants can achieve. Second, you must solve the barrel erosion problem that destroys the rails after relatively few shots. The barrel erosion challenge deserves special attention because it nearly killed American railgun development. Every time a projectile accelerates down the rails at hypersonic velocity, enormous electrical currents arc across the metal surfaces, essentially welding microscopic amounts of material from the rails to the projectile while simultaneously vaporizing other material. The temperatures and pressures involved are so extreme that even the most advanced alloys wear out rapidly. Early American prototypes could fire perhaps a dozen shots before the rails degraded so badly that performance collapsed and the barrel needed replacement. If you can't fire at least hundreds of rounds before replacing the barrel, the weapon becomes operationally impractical because you'd spend all your time swapping out worn barrels instead of fighting. Japanese engineers tackled this problem through meticulous materials science and clever engineering. Between 2016 and 2022, ATLA conducted extensive research into rail materials, projectile coatings, and the electromagnetic dynamics of the firing process. They tested countless combinations, measuring exactly how different materials behaved under the extreme conditions inside the railgun. By 2022, they achieved a breakthrough, a 120-shot durability test where the prototype consistently accelerated projectiles to over 2,000 meters per second without catastrophic barrel degradation. This might not sound impressive compared to conventional naval guns that fire thousands of rounds before barrel replacement, but it represented a quantum leap for railgun technology and proved the concept could work operationally. The research phase reached its peak in October 2023 with a historic milestone, the world's first successful at-sea firing test of a ship-mounted railgun. ATLA and the Japan Maritime Self-Defense Force installed an 8-ton, 6-meter-long railgun aboard JS Asuka, along with the massive support systems required to power it. These support systems occupied significant space. One 20-foot container housed the charging equipment, while 3 additional containers held a capacitor bank storing 5 megajoules of electrical energy. Capacitors are critical for railguns because they can discharge enormous amounts of stored electricity almost instantaneously, providing the power surge needed to launch each projectile. The ship's generators couldn't deliver sufficient power fast enough during firing, so the capacitors charge up between shots and then release their energy in microseconds when the trigger was pulled. The test firing validated every aspect of the system. Engineers launched 2 types of projectiles, a simplified integrated round for basic testing and a more complex 2-part armor-piercing round designed to defeat hardened targets. Each projectile weighed approximately 320 grams and measured about 160 millimeters in length, roughly the size of a large marker. When fired, these metal slugs accelerated to velocities approaching Mach 6.5, over 2,200 meters per second, generating kinetic energy comparable to conventional naval shells weighing 10 times as much. The physics are straightforward. Kinetic energy equals 1/2 mass times velocity squared. So doubling velocity quadruples energy. A tiny projectile moving at hypersonic velocity carries devastating power. The September 2025 test firing marked another crucial milestone by demonstrating accuracy against a real moving target at sea. Previous tests had fired at fixed targets or into open water to measure velocity and validate safety systems. Engaging an actual ship required integrating targeting sensors, fire control computers, and stabilization systems that compensate for the motion of both the firing platform and the target. Naval gunnery is extraordinarily complex because both ships are moving through 3-dimensional space affected by waves, wind, and currents. The fire control system must calculate the target's position when the projectile arrives, accounting for the projectile's flight time and trajectory. For a hypersonic projectile, these calculations become even more demanding because atmospheric effects at extreme velocities differ from those of subsonic shells. The successful hit demonstrated that Japanese engineers had solved not just the railgun itself, but the entire weapon system integration challenge. They had created a complete package including the electromagnetic launcher, power generation and storage systems, fire control radar, computers, and targeting sensors, all working together seamlessly. Admiral Akira Saito, commander of the Japan Maritime Self-Defense Force, personally visited Asuka in April 2025 to inspect the railgun and again later when the advanced turret-mounted version was installed. These high-level visits signal that Japan's military leadership views this technology as strategically critical and is committed to rapid fielding. The current research phase running from 2022 through 2026 focuses on transforming the experimental prototype into an operational gun system. This involves numerous refinements that seem unimportant, but are essential for combat effectiveness. Continuous firing capability is being developed because real combat requires sustained fire rates, not single shots with long reload times. The system must automatically reload projectiles, recharge capacitors, recalculate targeting solutions, and fire again within seconds. Flight stability of projectiles becomes critical at hypersonic velocities, where even tiny imperfections can cause tumbling that destroys accuracy. Japanese researchers are developing specialized projectile designs with fins, spin, or other stabilization features to ensure they fly true to the target. The fire control system development addresses the unique characteristics of railgun projectiles. Unlike conventional artillery, where shells follow ballistic arcs determined primarily by launch angle and velocity, railgun projectiles travel so fast that atmospheric effects become complex and highly variable. The projectiles experience tremendous aerodynamic heating and pressure, and their flight paths can be affected by winds, humidity, and temperature in ways that require sophisticated modeling. ATLA is developing specialized fire control algorithms that account for these factors, predicting impact points with accuracy sufficient to reliably hit targets at maximum range. Software development is just as critical as hardware, because a powerful gun means nothing if you can't hit what you're aiming at. Power generation and storage represents perhaps the greatest technical hurdle for fielding operational railguns. The prototype system on Asuka uses 5 megajoules per shot, an enormous amount of energy equivalent to detonating over 1 kilogram of TNT concentrated into a microsecond discharge. Future systems aim to scale up to 20 megajoules, 4 times more powerful, enabling larger projectiles or longer ranges. Generating and storing this much energy in the confined spaces aboard warships requires engineering breakthroughs in compact high-power systems. Large generators and massive capacitor banks would suffice for stationary land installations, but naval vessels have limited space and weight capacity. Every ton devoted to the railgun system is a ton that can't be used for armor, fuel, sensors, or other weapons. Japanese engineers are exploring multiple approaches to solve the power challenge. Advanced compact generators using new materials and designs can produce more electricity in smaller packages. Supercapacitors and advanced battery technologies store more energy per unit volume than conventional capacitors. Careful electrical engineering minimizes power losses during discharge, ensuring maximum energy reaches the projectile rather than being wasted as heat. The goal is a system compact enough to fit on destroyers and frigates rather than only on massive battleship-sized platforms, making the technology broadly deployable across the fleet. The operational applications being developed for Japanese railguns focus on 2 primary missions: missile defense and surface strike. For missile defense, the railgun addresses the terrifying challenge of hypersonic cruise missiles, weapons that scream toward targets at Mach 5+ speeds, maneuvering unpredictably to evade interception. Traditional surface-to-air missiles struggle against hypersonic threats because the engagement window is so brief and the targets are so fast and agile. A destroyer might have only seconds to detect, track, and engage an incoming hypersonic missile before it strikes. Railgun projectiles, themselves traveling at hypersonic velocities, can intercept these threats much more effectively than subsonic interceptor missiles. The railgun creates a layered defense where long-range missiles engage distant threats, while railguns handle close-in defense against anything that penetrates the outer defensive ring. The surface strike mission envisions using railguns for counter-battery fire against enemy artillery and for precision strikes against coastal installations or surface ships. Traditional naval guns have ranges of perhaps 15 to 20 miles, forcing ships to close within range of shore-based anti-ship missiles and artillery to provide fire support. Railguns could potentially engage targets at 50 to 100 miles or more, keeping friendly ships safely outside enemy threat ranges while still delivering devastating firepower. Against enemy warships, a railgun could fire continuously, saturating defenses with hypersonic projectiles that arrive faster than most point defense systems can respond. Land-based applications are also being considered, particularly for Japan's defense of remote islands in the Ryukyu chain, stretching toward Taiwan. These islands lack the infrastructure for large conventional artillery pieces, but a railgun system with its simplified logistics and ammunition could be deployed relatively easily. Shore-based railguns could defend against Chinese amphibious assault forces or provide fire support for Japanese ground forces. The challenge remains providing sufficient electrical power for sustained firing, which might require dedicated generators or potentially even small nuclear reactors for permanent installations. The strategic implications of Japan fielding operational railguns ripple across the entire Indo-Pacific region. China has spent decades building a massive navy specifically designed to contest control of the East and South China Seas, denying access to American and Allied forces. The People's Liberation Army Navy fields aircraft carriers, advanced destroyers, frigates, and hundreds of smaller vessels, plus thousands of shore-based anti-ship missiles. Chinese military doctrine emphasizes saturation attacks where dozens or hundreds of missiles and drones overwhelm defenses through sheer numbers. Traditional naval defenses struggle against this approach because interceptor missiles are expensive, and ships carry limited quantities. Once the missile magazines are exhausted, the ship becomes defenseless. Japanese railguns fundamentally counter this saturation attack doctrine. A destroyer equipped with a railgun and sufficient ammunition could engage hundreds of targets, limited only by the projectile magazine capacity and power generation, rather than by expensive missile counts. Each incoming Chinese missile or drone faces interception by a hypersonic metal slug, costing a fraction of what an interceptor missile runs. The economic advantage shifts decisively to the defender, making saturation attacks far less attractive as an offensive strategy. This forces Chinese planners to reconsider their entire approach to naval warfare in the region. Russia faces similar challenges in the northern Pacific waters around the Kuril Islands in the Sea of Okhotsk. Russian Pacific Fleet forces rely heavily on anti-ship missiles and submarines to counter American and Japanese naval superiority. The introduction of railguns complicates Russian attack planning by providing defenses that are far more difficult to overwhelm than current missile-based systems. Russian analysts are undoubtedly studying Japanese railgun developments closely, attempting to understand capabilities and develop countermeasures while simultaneously pursuing their own electromagnetic weapon programs that currently lag years behind Japan's progress. The failure of the American railgun program provides important context for understanding Japan's success. The United States Navy invested over $500 million and nearly 20 years developing electromagnetic railgun technology, achieving impressive results including projectiles traveling at Mach 7 and demonstrations of 100-plus nautical mile ranges. The Office of Naval Research and Contractors, like BAE Systems, built massive prototypes that shattered records and generated spectacular test footage of hypersonic projectiles obliterating targets. Yet in July 2021, the Navy officially paused railgun development, citing fiscal constraints, combat system integration challenges, and the maturation of alternative technologies. Several factors doomed the American program. The Pentagon's Strategic Capabilities Office realized around 2015 that the hypervelocity projectiles developed specifically for railguns could actually be fired from standard 5-inch naval guns already installed on destroyers and cruisers. While these conventional guns couldn't match railgun velocities, they could fire HVPs at Mach 3 to ranges of 10 to 30 miles, providing substantial capability improvements without requiring entirely new weapon systems. This discovery undermined the railgun's value proposition because the Navy could gain much of the benefit at far lower cost by simply developing new ammunition for existing guns. The integration challenges proved equally daunting. American warships like Arleigh Burke destroyers and Ticonderoga cruisers were designed decades ago with electrical systems sized for their original equipment. Retrofitting these ships with railguns would require massive electrical system upgrades that might cost as much as building new ships. The Zumwalt-class destroyers were specifically designed with powerful integrated electric propulsion systems that could theoretically support railguns, but only 3 Zumwalts were built, and they've been plagued with other problems. Without suitable platforms, the railgun remained an experimental curiosity rather than a deployable weapon. Budget pressures delivered the final blow. The Navy faced competing demands for limited resources, including new attack submarines, aircraft carriers, destroyer replacements, and countless other programs. Continuing to fund railgun development meant cutting other priorities, And given the technical challenges and uncertain timeline to operational deployment, railguns lost the bureaucratic battle. The program was paused, with residual research continuing at low levels, but active weapons development was halted. Japan succeeded where America failed, partly through different strategic choices and partly through methodical engineering excellence. Rather than attempting to retrofit existing ships, Japan built a dedicated testbed vessel specifically for experimental weapons, accepting from the beginning that early railgun systems would require specialized support. This allowed engineers to focus on making the railgun itself work without wrestling with integration into legacy platforms. The Asuka provides ideal conditions for testing with ample space, flexible electrical systems, and instrumentation optimized for gathering performance data. Japanese researchers also took a more conservative approach to scaling, starting with relatively modest 40mm projectiles and 5 megajoule energy levels, rather than immediately pursuing the massive 33 megajoule systems the Americans demonstrated. This incremental methodology allowed solving technical problems at manageable scale before attempting to push into higher performance regimes where challenges multiply. The emphasis on barrel durability as a fundamental requirement from day one prevented the program from achieving spectacular performance numbers that proved operationally useless due to rapid barrel wear. The collaboration with international partners has accelerated Japanese progress while building coalitions around the technology. In May 2024, Japan's Ministry of Defense signed implementation arrangements with France and Germany to facilitate information exchange and assess the potential for joint railgun development. The agreement involves France's and Germany's defense ministries, along with the joint French-German St. Louis Research Institute, pooling expertise and resources. One Japanese engineer from ATLA was seconded to a U.S. Navy research institution from January 2023 through June 2024, reviewing American facilities and interviewing researchers who worked on electromagnetic weapons. This exchange provided insights into what worked and what didn't during American development, allowing Japan to avoid repeating mistakes. Japan is challenging the pacifist limits set after the Second World War. Once restricted from a proper military and dependent on allies for defense, this nation is breaking from its past. In a bold move that no other country saw coming, Japan has teamed up with Italy and Great Britain to develop a powerful sixth-generation fighter jet through the Global Combat Air Program. This high-tech aircraft marks a significant step toward Japan's ambition to design and produce combat jets. Could this be the start of Japan's military resurgence? What are the capabilities of this new generation fighter? Join us as we reveal the intriguing details of Japan's new sixth-generation fighter jet with capabilities that would change the battlefield forever. Before Japan shocked the world with the announcement of a new sixth-generation fighter jet, the nation had been quietly working on its military comeback. For decades, Japan followed a pacifist path after the Second World War, avoiding offensive military power to respect its post-war constitution and avoid angering its neighbors. However, rising tensions with China and concerns about North Korea's missiles led Japan to rethink its stance. Making a strategic decision, Japan's government recently approved new policies allowing it to strike other nations if threatened. Prime Minister Fumio Kishida argued that as missile technology advances globally, Japan needs a stronger defense to deter potential attacks. The decision followed pressure from the United States, which has urged Japan to take on a larger defense role to counter China's growing military power. The new policy will boost Japan's defense spending to 2% of its GDP by 2027, doubling its previous limit. This increase would help Japan buy advanced weapons from the United States, like Tomahawk missiles, and develop its advanced fighter jets, hypersonic missiles, and armed drones. However, the policy claims that Japan's defense will remain strictly protective, avoiding preemptive strikes or threats to other countries. China, unsurprisingly, criticized Japan's move, accusing it of exaggerating the China threat to justify its military buildup. Despite the criticism, Japan is determined to strengthen its defenses, aiming to become more self-reliant in securing its territory. Now, with its sixth-generation fighter jet being developed with Italy and Great Britain, the world is eager to witness the technological capabilities this fighter jet can deliver. Many countries are also working on their sixth-generation fighter jets, but they all share some basic features. These advanced jets will be developed using digital engineering and artificial intelligence to help pilots make decisions quickly in battle. They will also have powerful communication systems that can transfer large amounts of data between aircraft, the option to fly without a pilot, and better human system integration, like virtual cockpits shown on helmet displays instead of traditional panels. Additionally, these fighters will carry hypersonic and energy weapons and have advanced stealth abilities to avoid detection from infrared tracking systems. Japan has long considered building its fighter jet, but it relied on licensed projects from other countries for years. For example, the Mitsubishi F-2, introduced in the 1990s, is a modified version of the American F-16 Fighting Falcon. Before that, there was the Mitsubishi F-1, a light attack aircraft from the 1970s, which is often compared to the British-French Seppicat Jaguar. By 2010, Japan's Ministry of Defense realized the need for a new fighter to replace the aging Mitsubishi F-2 fleet. The need became more urgent as China rapidly advanced its air force. Russian aircrafts often violated Japan's airspace, and North Korea's missile threats increased. In response, Japan developed the concept of the I-3 fighter, standing for informed, intelligent, and instantaneous. This jet would be a counter-stealth fighter with a combat information system that includes a high-power radar, advanced sensors, and tactical communication with external sensor nodes and UAVs. These features aim to give Japan an edge in regional air superiority. The I-3 fighter was designed to have strong stealth capabilities, advanced sensors, and networked fire control, allowing it to share data and target information with other aircraft. It could also carry futuristic weapons, like combat lasers, known as light-speed weapons, to shoot down threats instantly. By 2018, Japan's IHI Corporation created a prototype of the IHI XF-91 engine, a key part of the jet's development. However, in 2020, the Ministry of Defense officially shifted from the I-3 fighter to the FX program, with Mitsubishi Heavy Industries leading the project. Another reason Japan pushed to create its own advanced fighter is that it could not buy the F-22 Raptor from the United States. The Obi Amendment prevented the sale of the F-22 to any foreign country, making it impossible for Japan to acquire the world's top air superiority fighter. Now let's get into the details of this new air fighter that has piqued the curiosity of several nations across the globe. The Mitsubishi FX is truly exceptional. It was nicknamed Godzilla by an Aviation Week writer due to its large size, even bigger than the F-22 Raptor. Unlike older jets that used hydraulic systems, the FX uses electric drives. This decision wasn't just for innovation. The aircraft's complex design needed space for air intakes, internal weapons compartments, and other tech. Using electric drives made the jet lighter, more agile, and easier to design. To reduce weight further, Mitsubishi engineers replaced traditional fasteners with adhesive molding, literally gluing parts together. They also used lightweight materials like aluminum alloys and carbon fiber reinforced polymers. These choices not only made the jet lighter, but also helped with its stealth capabilities. The jet has a serpentine air duct and an internal weapons bay to minimize its radar cross-section. To make it even harder to detect, they added electromagnetic wave absorbers to the air ducts and engines. A standout feature of the FX is its radar system, designed to detect other stealth aircraft. It uses an active electronically scanned array radar, similar to the one on the F-35 Lightning II. There are also passive sensors and infrared cameras, making it capable of tracking enemy aircraft without giving away its position. To prevent the aircraft from overheating due to all this technology, Mitsubishi installed a special cooling system that uses a mix of vapor compression and liquid cooling. Powering the FX is the powerful XF-9 engine developed by IHI Corporation. It's designed to be thin, with an inlet 30% smaller than the engine on the Mitsubishi F2, yet it generates a massive 360 kilowatts of power through two of these engines. The engines also have 3D nozzles that can deflect thrust by 20 degrees, giving the aircraft high maneuverability and agility. When it comes to weapons, the FX is set to carry the AWACS-3 supersonic anti-ship missile, also developed by Mitsubishi. There are plans for two versions, the ASM-3A with extended range and the ASM-3 Kai, though details about the latter are still unknown. These advanced weapons are expected to replace the Mitsubishi F2, set to be retired in the 2030s. But how does the Global Combat Air Program fit into this? In 2022, there were rumors that Japan and the UK were planning to combine the FX with the UK's Tempest fighter program. This was confirmed in December 2022, solidifying a partnership that also includes Italy. Interestingly, the UK initially tried to team up with France and Germany through the Future Combat Air System. However, disagreements and conflicts pushed the UK to work with Japan and Italy instead. This partnership is valuable for Japan because, despite its high-tech capabilities, the country has limited experience in exporting military aircraft. The UK, meanwhile, gains a reliable, advanced partner without the internal conflicts that disrupted its earlier plans. Working together, these countries aim to create a cutting-edge, sixth-generation stealth fighter that could redefine air combat technology. Key roles are divided among major companies. Japan's Mitsubishi, Heavy Industries, and the UK's BAE Systems are the main contractors. BAE also works on the airframe, while Japan's IHI Corporation and Rolls-Royce focus on the engine. Italy's Leonardo handles electronics, and MBDA UK is in charge of missile development. After Japan and Britain agreed to build this fighter, they began working on sensor systems under a project named Jaguar or Japan and Great Britain Universal Advanced Radar Frequency System. The new fighter is expected to be about 30% larger than the Eurofighter Typhoon, and its empty weight is similar to the American F-15 Eagle. The Delta wing has a steep 50-degree sweep, stretching about 54 feet with a total wing area of 12,200 square feet, almost as large as the Airbus A320's wing. A model of this aircraft was first shown at the Farnborough Air Show in 2024. The design has a trimmed Delta wing, giving it greater speed, range, and the ability to carry more weapons and fuel. However, its maneuverability might not match that of Japan's original Mitsubishi FX concept. British aviation journalist Gareth Jennings compared the G-SCAP's large wingspan to the retired American F-111 Aardvark bomber. The F-111 relied on low-altitude flying to avoid radar, while the G-SCAP jet aimed to use stealth and long-range missiles for defense. This approach resembles the proposed FB-22, a long-range bomber variant of the F-22 Raptor that never entered production. Unlike the FB-22, which was designed as a companion to the F-22, the GCAP aims to balance air-to-air combat and ground attacks. All three partner nations currently use the F-35B stealth fighters, except the UK, which also operates the ground-based F-35A. Yet they still needed a more versatile jet that could carry more weapons than the F-35 and could be exported without the strict restrictions faced by the American F-22 Raptor. Interestingly, Japan is planning to use its own advanced missile systems on its new sixth-generation fighter jet. Some of these missiles include the MBDA Meteor, the Spear-3, and the ASM-3, a Japanese anti-ship missile. They are also developing a new medium-range air-to-air missile known as the Joint New Air-to-Air Missile in collaboration with Britain. Rumors say this missile will have a Japanese-designed radar system in the front and a British-built Meteor ramjet engine in the back. However, it might not be as fast as the Meteor, which can reach speeds above Mach 4. The J&M speed is expected to be around Mach 3.5. As for the timeline, the first flight of a Tempest concept demonstrator, a prototype to test and refine new technologies, is set for 2027. According to the UK Ministry of Defence's Director of Future Combat Air, this demonstrator will give a good idea of what the final GSAP fighter jet will be like. However, the actual operational use of the jet, developed together by Japan, Britain, and Italy, isn't expected before 2035. Building a stealth fighter takes a lot of time and money, even for big countries like the United States. In fact, the United States has paused its own sixth-generation fighter project, the Next Generation Air Dominance Program, likely due to the same reasons. This raises an interesting question. Can GCAP progress faster than the NGAD, or will it face delays like the European Future Combat Air System project? The FCAS, a collaboration between France, Germany, and Spain, has experienced slowdowns because of disagreements over responsibilities and budgets. Given the complexity and cost of developing advanced fighter jets, GSAP might also struggle to stay on schedule. Unfortunately, not everyone agrees with this new direction of Japan's growing military power. Kyoji Yanagasawa, a former defense official, is one of the few openly critical voices. He thinks having strike capabilities won't truly scare off potential enemies. Instead, he believes Japan should focus on diplomatic efforts to avoid conflict. To really have a deterrent, we would need to be able to almost completely stop an enemy's missiles. We can't do that, Yanagasawa argues. Not only do we lack a real deterrent, but this approach could also lead to a counterattack against us. Yanagasawa worries that increasing Japan's military strength might do more harm than good. He feels that building up weapons could provoke neighboring countries and make Japan a bigger target. His stance highlights a tough choice for Japan, balancing the need to protect itself while trying not to escalate tensions in the region. Many experts believe that Japan's decision to strengthen its military is a response to a rapidly changing world. As China expands its influence and North Korea continues to develop its nuclear program, Japan fears being left vulnerable. The country also worries that its main ally, the United States, may not always be able to offer full protection, especially if faced with multiple threats worldwide. On the other hand, Japan's growing military power could signal a major change in the region. For decades, Japan has relied on the United States military for protection, maintaining a self-defense approach. However, with rising threats from its neighbors, Japan's government feels it needs a stronger stance. The decision to develop strike capabilities is part of a broader strategy to modernize its military and increase its ability to respond quickly to threats. The debate over Japan's new defense strategy shows the country's struggle to find a balance between peace and security. While most citizens support the idea of having stronger defenses, some worry about the long-term effects. If Japan increases its military strength, will it help protect the country or lead to more tension and instability in East Asia? As Japan moves forward, it faces a critical choice: strengthen its military to prepare for potential conflicts or focus on diplomacy to maintain peace. However, if China decides to invade Taiwan, Japan has indicated it may join the United States in defending the island. This stance could make Japanese military bases potential targets for Chinese attacks. Discussions in Japan suggest that if its territory is hit, the country might launch a counterattack, aiming at enemy bases or command centers. They could even strike if they believe an attack is about to happen. But this raises legal questions. Yasuo Hasebi, a constitutional law expert at Waseda University, explains that the legality of such a move is unclear. We only know whether an attack is preemptive or not, he says, after it is carried out. However, he believes the government might argue that simply having weapons for defense, without using them, could still fit the limits of Japan's pacifist constitution. Despite these uncertainties, the Japanese government strongly claims that this approach is constitutional. Hasebi points out that since the government insists it is legal, debating it is challenging. Interestingly, there hasn't been much pushback from Japan's civil society, media, courts, or opposition parties about how this shift in military policy aligns with the Constitution. The government hasn't provided a clear explanation of how these actions comply with the country's laws. From the perspective of the United States, Japan's increased military spending and defense development could be seen as a double-edged sword. Zach Cooper, a senior fellow at the American Enterprise Institute, notes that Japan is investing in military capabilities that the United States already provides through their alliance. He suggests that this overlap is partly because of concerns that the United States may not always be a reliable partner. The uncertainty stems from the approach of President Donald Trump, who questioned the value of long-standing alliances. Many in Tokyo, Cooper says, are unsure if the United States will maintain the same level of commitment to their alliance in the next 5, 10, or 15 years. Japan's effort to strengthen its defense is seen as a way to reduce its dependency on the United States while valuing the alliance. Japan's approach reflects a lesson from Ukraine's fight against Russia. Observers believe that the more a nation takes charge of its defense, the more it inspires allies to help. Japan may hope that by showing it is ready to defend itself, It will encourage more substantial support from its partners, especially the United States. Japan's increased defense spending, willingness to counter threats, and closer cooperation with the United States signal a significant change in its defense policy. While these actions are intended to protect Japan, they could also reshape the balance of power in the region. As tensions rise in East Asia, Japan's decisions may have a lasting impact not just on its security, but also on its role on the global stage. As regards the United States' sixth-generation aircraft, President Donald Trump is set to reveal the winner of the massive $20 billion contract for a next-gen fighter jet as soon as Friday. This big announcement could shape the future of American air power and determine whether Lockheed Martin or Boeing will lead the charge. The contract, part of the next-generation air dominance program, aims to replace the aging F-22 Raptor with a high-tech crewed fighter that will work alongside drones. The plane's design is a tightly guarded secret, but will likely feature stealth abilities, advanced sensors, and powerful engines. An official from the U.S. government hinted that Trump would make the announcement alongside Secretary of Defense Pete Hegseth from the Oval Office. As the decision looms, Boeing and Lockheed stay silent, not commenting on the situation. Trump's push for this project comes even as his administration works to cut costs across the U.S. government. Just a day before, he signed an executive order to dismantle the Department of Education, showing his strong stance on reducing government spending. Yet this NGAD program is a crucial step in keeping pace with rising threats from nations like China and Russia. Initially, the NGAD program had faced uncertainty due to budget issues and concerns over the high costs of other Air Force projects. Even billionaire and presidential advisor Elon Musk expressed doubts, suggesting that cheaper drones might be more effective than advanced crewed fighter jets. Despite these challenges, a finalized design for the NGAD fighter was chosen last year, and the upcoming announcement signals that the project is moving forward. For Boeing, winning this contract could bring a much-needed boost to its struggling fighter jet production in St. Louis, Missouri. If it loses, it could face further difficulties as it navigates setbacks in both its commercial and defense sectors. On the other hand, Lockheed, already a giant in the defense industry, would likely focus more on its F-35 program and the international sales of its F-16s if it misses out. With tensions between China and the United States growing more intense, America's allies, especially Japan, have been left with no choice but to find ways to defend themselves against future threats. Japan has gone the extra mile, developing aircraft unlike anything ever seen in aerial warfare. Armed with technology so advanced that even European nations are eager to collaborate, Japan is finally stepping up to claim its place among the world's military powers. Could this be the beginning of Japan's military resurgence? What can this next-generation fighter truly do? Join us as we reveal the groundbreaking details of the new bombers Japan has just added to its arsenal. After the Second World War, Japan became very cautious about rebuilding its military, especially its air force, which now appears outdated compared to that of other countries. The memories of Hiroshima and Nagasaki still remind everyone of how terrible war can be. Japan's new constitution, drafted with the help of the United States after the war, took a firm stand against war. In Article 9, Japan relinquished its right to wage war or maintain military forces for aggression, limiting its forces to self-defense purposes only. Japan also made a deal with the United States for protection. American troops, including air forces, stayed in Japan to defend the country. This allowed Japan to rebuild its cities, businesses, and industries without undue concern for war. But as time went on, growing problems with China and fears about North Korea's missiles made Japan change its thinking. China's rapid rise in both economic and military strength began to appear more unfriendly toward Japan. Because Japan supported Taiwan and worked closely with the United States, China hit back with trade bans and boycotts. Behind the scenes, China also used cyber attacks and spying. They broke into Japan's government and business systems, attempting to steal sensitive secrets related to defense and technology. China sent more ships and planes close to Japan's borders. They started doing regular live-fire drills and even launched ballistic missiles near Taiwan, one of Japan's close partners. With danger rising, Japan recognized the need to enhance its air force rather than relying solely on others, especially since China and Russia are now introducing more advanced fighter jets. In a big move, Japan's leaders have recently agreed on new rules that would enable the country to respond more effectively to threats. Former Prime Minister Fumio Kishida stated that, with missiles becoming faster and more deadly around the world, Japan must strengthen its defense to deter future attacks. This decision also followed the United States urging of Japan to assume a greater role in containing China's expanding military. This new plan will increase its defense budget to 2% of its economy by 2027, doubling the amount it currently spends. With more money, Japan will buy advanced weapons from the United States like Tomahawk missiles and work on building its top-level fighter jets, super-fast missiles, and armed drones. Initially, Japan sought to acquire the Lockheed Martin F-22 Raptor. However, the United States refused to sell the jet to any other country, thereby keeping its technology safe and leaving Japan at a disadvantage. So Japan made a bold choice to design and build its sixth-generation fighter jet. It's a challenging project, but if they succeed, Japan could end up producing one of the world's best warplanes and become a major player in the arms market. Between 2009 and 2010, Japan's Ministry of Defense took a deep look into fighter jet technology. From this work came the idea of the I-3 fighter, which stands for Informed, Intelligent, and Instantaneous. This jet was designed to be a stealth fighter capable of detecting and engaging other stealthy planes. It would come equipped with a powerful radar system, smart sensors, and the capability to communicate with external drones and sensor stations during battles. All these features were meant to give Japan a big advantage in controlling the skies around its region. The I-3 fighter could also carry new types of weapons, such as laser guns, known as light-speed weapons, that could instantly destroy incoming threats. As expected, China responded to Japan's plan with harsh words, accusing Japan of fabricating the China threat as a pretext for building more weapons. However, Japan is pushing forward, determined to rely more on itself and defend its territory. To turn their ideas into reality, Japan created a test plane called the Mitsubishi X-2 Shinshin. The X-2 was designed with a look similar to that of modern fifth-generation fighters, such as the Lockheed F-22 Raptor. Its size was comparable to that of the Swedish Saab JAS 39 Gripen. Measuring approximately 14 meters in length with a wingspan of 9 meters, it weighed almost 13 tons and was equipped with strong turbojet engines featuring 3D thrust control, which provided it with remarkable agility and the ability to fly at supersonic speeds. One of the most notable features of the X-2 was its fly-by-optics system. Instead of using traditional cables, it utilizes optical fibers, which enable faster data sharing and better noise handling. Its radar, called the multifunction RF sensor, was built with an active electronically scanned array, known as AESA technology, allowing it to switch across different signals for jamming, communication, and possibly even using microwave weapons. Another notable feature was its self-repairing flight control system. If the plane's flight surfaces got damaged, it could detect the problem and adjust by using the parts that still worked, keeping the jet flying safely. For its test flights, the X-2 used two XF-5 engines. The work was led by Japan's Acquisition Technology and Logistics Agency. They made a small demo plane called the Advanced Technology Demonstrator, or ATDX for short, which flew 34 missions in 2016 and 2017. ATLA also ran 14 other programs focused on building the key components needed for a real stealth fighter, such as improved sensors, faster data links, and concealed weapon bays. The prototype was a big success. Many of the new systems tested on it will likely be used in Japan's future sixth-generation fighter jet. The twin-engine plane had a sleek and smooth shape, standing about 4.51 meters tall. Its cropped delta wings and special extensions allowed it to keep flying safely even at high angles. Two vertical fins at the rear helped improve both its flight capabilities and stealth. It was piloted by a single pilot and featured a retractable tricycle landing gear setup, smooth control surfaces, and two rectangular air intakes positioned adjacent to the cockpit. The special S-duct design also made its airflow smoother and more conducive to speed. After the success of the X-2 project, Japan's Ministry of Defense started working on the Mitsubishi FX in 2020. This new twin-engine stealth fighter is designed for air battles and is planned to be even larger than the F-22, which has earned it the nickname Godzilla. Its large size would give it a longer flight range and the ability to carry a greater number of weapons. It is also designed to have a robust network system and carry more missiles than the F-35. Engineers experimented with various exterior designs using 3D models and specialized computer programs. The primary goals were to make it extremely fast, highly agile, and exceptionally stealthy. To make it lighter and more flexible, the FX would ditch hydraulic systems and utilize electronic components instead. It would also use strong glue molds instead of regular bolts and screws. 2 XF-9 engines would power the plane, providing it with more than 20 tons of thrust. These engines would have special 3D thrust nozzles to help them turn more quickly and remain hidden. For its weapons and defense, the FX would feature an advanced mix of sensors to track and engage stealthy enemy planes. It would carry an active electronically scanned radar, a passive radio wave sensor, and an infrared camera. All of these would utilize gallium nitride technology to better detect targets that are normally difficult to see. The new jet would also feature a sophisticated radio system that could jam enemy signals worldwide, enabling it to intercept and counter incoming missiles. Pilots would receive a high-tech helmet equipped with a wide field of view, dual-eye displays, colorful screens, voice control, and 3D sound. The FX's stealth features would include twisted air ducts, hidden weapon bays, materials that absorb radar waves, and new metamaterials to make it even harder to detect. A plasma stealth system would generate short plasma bursts to deflect radar waves, thereby further protecting the plane. Beyond conventional armaments, the FX will be armed with a microwave cannon to disrupt incoming missiles. It will also have the ability to deploy combat support unmanned aircraft drones, serving as loyal wingmen to the fighter. These drones will aid in target identification, munition deployment, and the deflection of incoming missiles. If the FX Godzilla lives up to even a fraction of its potential, it could provide the Japanese armed forces with a formidable warplane surpassing anything in today's skies. Furthermore, it has the potential to propel Japan into the global weapons development market, solidifying its position as a military manufacturing powerhouse. Another important job for the FX Godzilla is to replace Japan's current F-2 fighter jets during the 2030s. It's clear that Japan also draws some ideas from the US regarding the FX's design and functionality. Japan even bought some F-35s to use alongside the FX once it is ready. In 2022, rumors started flying that Japan and the UK might join forces by merging Japan's FX project with the UK's Tempest fighter program. By December 2022, the partnership was officially announced, and Italy joined the team as well. Initially, the UK sought to collaborate with France and Germany through a program called the Future Combat Air System. However, after numerous arguments and delays, the UK ultimately decided to collaborate with Japan and Italy instead. This new collaboration is a significant win for both parties. Japan secures strong partners who can help it sell military planes overseas, an area where it lacks substantial experience and expertise. The UK gets serious partners without the problems it faced before. Together, they aim to develop a powerful 6th-generation stealth fighter that could revolutionize the future of air combat. Big companies were given key tasks. Mitsubishi Heavy Industries from Japan and BAE Systems from the UK are leading the project. BAE is also working on the main body of the jet. Japan's IHI Corporation and Rolls-Royce are building the engines. Italy's Leonardo is responsible for the electronics, while MBDA UK handles the missile systems. After Japan and Britain teamed up, they also began working together on radar systems through a project called Jaguar, an acronym for Japan and Great Britain's Universal Advanced Radar Frequency System. The new fighter will be about 30% bigger than the Eurofighter Typhoon. Its weight without fuel will be close to that of the American F-15 Eagle. The plane will have a sharp delta wing with a 50-degree sweep. The wingspan will be around 54 feet, and the total wing area will be about 12,200 square feet, almost the same as the wing size of an Airbus A320. A model of the new fighter was first shown at the Farnborough Air Show in 2024. It features a trimmed delta wing, which enables it to fly faster, travel farther, and carry more weapons and fuel. However, it may not be as adept at quick turns and sharp maneuvers as Japan's original FX design. British aviation journalist Gareth Jennings pointed out that the G-SHAP's broad wings look a lot like those of the old American F-111 Aardvark bomber. The F-111 used to fly low to stay hidden from radar, but the G-SHAP will mainly depend on stealth and long-range missiles to remain safe. This plan is similar to the FB-22, a bomber version of the F-22 Raptor that never entered service. Unlike the FB-22, which was built solely for support, the GCAP is designed to engage other planes and strike ground targets. All three countries working on the G-SHAP already use F-35B stealth fighters, except the UK, which also flies the F-35A. However, they still sought a jet that could carry more weapons than the F-35 and could be sold to other countries without the stringent restrictions associated with the American F-22 Raptor. Japan also plans to fit the G-SHAP with its high-tech missile systems. These will include the MBD-A Meteor, the Spear-3, and the ASM-3, which is a Japanese anti-ship missile. Japan and Britain are also collaborating to develop a new medium-range air-to-air missile, known as the Joint New Air-to-Air Missile. Rumor has it that the JN-8M will feature a radar system manufactured by Japan at the front and a Meteor ramjet engine from Britain at the rear. Still, it may be slower than the Meteor, which can travel at over Mach 4. The JN-8M's top speed is expected to be around Mach 3.5. As for the schedule, the first flight of a Tempest concept demonstrator, a prototype built to test new technology, is planned for 2027. According to the UK Ministry of Defence's Director for Future Combat Air, this test plane will give a strong idea of what the final GEAP fighter will look like. Work on the joint engine demonstrator began in 2024, with the UK investing an initial £30 million in planning, digital design, and innovative construction methods. An additional £200 million from the UK will be allocated toward building a full-size engine for testing. This work will also create many skilled jobs, including at Rolls-Royce's Filton site in Bristol. The first flight of the Tempest is expected to happen in 2035. It will eventually replace the Eurofighter Typhoon in Italy and the UK, as well as the Saab Gripen in Sweden. During its production, they plan to use 3D printing to make parts. Leonardo is also building a new type of radar system for the Tempest. Instead of using a single large radar, this new system will utilize numerous small antennas and mini receivers to collect vast amounts of information from both the sky and the ground. Like other sixth-generation jets, the Tempest is likely to utilize artificial intelligence to control drones, building upon the concept of the loyal wingman. The cockpit will feature augmented reality, making the plane even more advanced. Fast progress and teamwork between countries will be crucial if the Tempest hopes to keep pace with China and Russia, who are also developing powerful new jets. Still, not everyone is pleased about Japan's more ambitious military plans. Kyoji Yanagasawa, a former defense leader, is one of the few who have spoken out. He says that having more potent weapons will not scare away enemies. Instead, he thinks Japan should focus more on talking and making peace to avoid wars. Yanagasawa worries that if Japan builds up its army too much, it could cause more trouble than it solves. He believes that growing the military might deter neighboring countries and make Japan a more attractive target. His view focuses on the difficult choice Japan faces: how to maintain safety without exacerbating tensions with its neighbors. Many experts believe Japan's push to enhance its military capabilities stems from a rapidly changing world. With China growing stronger and North Korea building up its nuclear weapons, Japan feels it might be left exposed. There are also concerns that the United States, Japan's largest ally, may not always be able to fully protect it, especially if problems erupt in different parts of the world simultaneously. The debate over Japan's new defense plans shows the complex situation the country faces as it seeks to strike a balance between peace and security. While many people agree that Japan should be able to defend itself more effectively, others are concerned about potential future developments. If Japan overextends its military, will it truly make the country safer, or will it merely add more tension to East Asia? Yasuo Hasebe, a constitutional law expert at Waseda University, mentioned how hard it is to know if a strike is truly preemptive until after it happens. He also argued that the government could claim that simply possessing these weapons for defense, even if they are never used, still aligns with Japan's peace-focused constitution. Although the law isn't clear on the matter, the government firmly insists that its plan is legal. Hasebe noted that because the government claims it is allowed, questioning it becomes very difficult. Surprisingly, there has been little resistance from Japan's public, media, courts, or opposition parties regarding whether this new military path aligns with the Constitution. The government has also not clearly explained how its actions comply with the law. From the U.S. perspective, Japan's growing military presence can be viewed in two ways. Zach Cooper, a senior fellow at the American Enterprise Institute, notes that Japan is bolstering its weapons and defenses, which the U.S. already supplies through its alliance with Japan. He believes part of the reason is Japan's fear that America might not always be a steady partner. That fear partly comes from the time when President Donald Trump questioned the value of old alliances. Japan's plan also shows that it learned from Ukraine's fight against Russia. Experts believe that when a country demonstrates its commitment to self-defense, its allies are more likely to step in and provide assistance. Japan hopes that by demonstrating its ability to stand up for itself, it will receive even more substantial support, especially from the United States. Most people thought the YF-23 was done for good. They saw it as just another what-if story gathering dust in aviation history books. However, sometimes the best ideas just need the right moment to shine, and that moment seems to be now. Japan's throwing serious money behind a complete reimagining of this aircraft. This is a ground-up redesign that takes everything that made the original YF-23 special and cranks it up to 11. So everyone is wondering, why resurrect something that was supposedly inferior back in the day? And how did it turn into one of the most cutting-edge fighter projects out there? Join us as we dig into how this old airframe ended up leading the conversation about tomorrow's air power. The Northrop YF-23, also called the Black Widow II, is one of the most fascinating jets the United States Air Force has ever flown. Only two were built between the late 1980s and early 1990s as part of something called the Advanced Tactical Fighter Competition. The goal was to build a next-generation replacement for the F-15 Eagle that could handle rising Soviet threats like the Sukhoi 27 and the MiG-29. Northrop partnered with McDonnell Douglas, while their competition was a powerhouse trio, Lockheed, Boeing, and General Dynamics, who came up with the YF-23. After nearly 4 years of designing, testing, and evaluating, the Air Force went with Lockheed's jet. It eventually became the F-22 Raptor. And just like that, the YF-23 project was shut down. But here's the twist. Over time, the YF-23 didn't fade away. Instead, it built a cult following among aviation fans. A lot of them believe it was the better fighter. Today, there's growing buzz around the YF-23, and it's coming from an unexpected place: Japan. Why? Japan is developing its own advanced fighter, and some voices in the defense world have floated the idea that Japan might revive or even adapt the YF-23 design for its F-3 program. In 1981, the U.S. Air Force put out a request for information on the ATF program, looking for an aircraft that could pull off something pretty ambitious, combining stealth technology with high speed, agility, and cutting-edge avionics all in one package. Northrop's stealth team, many of whom had already cut their teeth working on the B-2 bomber, dove into exploring 3 different approaches. They considered an agile fighter featuring canted tails, an ultra-stealthy design they dubbed the Christmas tree, and what became known as the high stealth fighter concept, which tried to strike the right balance between staying invisible and remaining maneuverable. The HSF design was particularly interesting, incorporating diamond-shaped wings and all-moving V-tails that the engineers nicknamed rudder vaders. They also integrated engine exhaust troughs and made sure all the edges lined up just right to minimize both radar and infrared signatures. The whole idea of a Japanese version of the YF-23 mostly comes from speculative media stories and defense analysts trying to picture how Northrop might get involved in Japan's F-3 fighter program. According to a report from DJI magazine, Northrop Grumman put together a stealth fighter concept for Japan sometime around the year 2018. And yes, it looked a lot like the YF-23. The article says Northrop responded to Japan's request for information and even had early talks with defense officials. Instead of pitching a full design, they offered a menu of technologies, which is kind of a mix-and-match toolkit. Still, some writers started wondering if Northrop might tweak the YF-23 to fit what Tokyo was looking for. Interest around the idea kept growing, thanks to the jet's reputation. Some observers even claimed it outperformed the F-22. Back in 2018, Reuters reported that Japan was hoping to bring in international partners to help cover development costs, which were expected to top $40 billion, and to tap into advanced tech that would otherwise take years to build from scratch. Both Lockheed Martin and Northrop Grumman responded to Japan's outreach, but Tokyo made it clear the core systems like avionics, sensors, and engines had to be developed in Japan. By October of 2020, Japan's Ministry of Defense picked Mitsubishi Heavy Industries, or MHI, as the lead contractor for the fighter program. MHI would head the project while still looking for a foreign partner. Then in 2022, Japan made a big move. It merged its FX program with the UK's Tempest and Italy's Future Combat Air System. Together, they formed the Global Combat Air Program, GCAP. That decision officially closed the door on a solo Japanese fighter and any chance of reviving the YF-23 for Tokyo. The program focuses on 5 key goals: dominating future air battles, integrating next-gen tech, making upgrades easy, involving Japan's domestic industry, and keeping costs under control. Japan's vision includes radar systems that can spot stealth aircraft, plus the ability to receive targeting data from drones, other jets, and airborne early warning planes. They are also studying advanced sensor fusion, network battlespace management, and high-res infrared imaging. Here is what that looks like in practice. A Japanese F-3 on patrol over the East China Sea has its radar detect what might be a stealth aircraft trying to stay hidden, maybe a Chinese J-20 operating at long range. At the same time, the fighter receives targeting information sent directly from an unmanned drone flying ahead, plus data from other F-3 aircraft in the area, and one of those big airborne radar planes circling further back. All this information gets processed together in real time. The pilot doesn't just see one radar screen anymore. They get a complete picture that combines infrared imaging, showing heat signatures, electronic signals the aircraft picks up, and position data from multiple sources. The system automatically sorts through all this information and presents the most important threats first. When the pilot decides to engage, the decision is not based on what one aircraft can see. The targeting data has been cross-checked and verified by multiple platforms, all working together as one connected network. The missile guidance can even be updated mid-flight using information from any of these sources. The fighter is expected to feature conformal radar antennas, electronic support gear, and countermeasures to jam or deceive enemy systems. Japan's defense minister, Taro Kono, has said the FX will be highly networked and carry more missiles than the F-35. Here is what that means in real terms. Instead of having a traditional radar dish that sticks out and creates drag, the FX will have radar antennas that are molded right into the skin of the aircraft. Pilots won't even see them from the outside, but they'll be scanning in all directions. The electronic support equipment works like advanced ears. It listens for enemy radar signals, radio communications, and electronic emissions to figure out what threats are out there. When something hostile tries to lock onto the aircraft, the countermeasures kick in. These systems can jam enemy radars by flooding them with false signals, or they can send out decoy signals that make the aircraft appear to be somewhere it's not. Kono's comment about carrying more missiles than the F-35 is significant. The F-35 typically carries 4 missiles internally to maintain its stealth profile, or up to 6 if they are willing to compromise stealth by mounting some externally. The FX is being designed with larger internal weapon bays, so it might carry 6 or 8 missiles while staying completely stealthy. Japan's F-3, now part of the GCAP initiative, will be a brand new aircraft built around Japan's own needs, tech, and industrial goals. Still, the YF-23's influence is hard to ignore. Its design philosophy, stealth-first shaping, long-range capability, and the reminder that the best ideas don't always win continue to shape how future fighters are imagined. So why does the YF-23 still turn heads? Because it wasn't just a jet, it was a pivot point in fighter design. It illustrated how radically different philosophies, politics, marketing muscle, and export controls can impact which aircraft gets built and which one fades into the footnotes. Even though the world may not see a Japanese YF-23, Japan's new fighter program is chasing some of the exact same ideas that made Northrop's original design so compelling. The F-3, sometimes called FX, is being built as a sixth-generation fighter, and when people look at what they are trying to achieve, long-range, heavy weapons capacity, advanced networking, it's like they took notes from the YF-23 playbook. Japan's laid out 5 main goals for this project: dominating future air battles, being able to integrate whatever new tech comes along, making upgrades simple, getting Japanese companies involved, and keeping costs reasonable. Pretty straightforward stuff, but the devil's in the details. What's interesting is how Japan's thinking about sensors and connectivity. They want advanced radar systems that can spot stealth aircraft, which is no small feat. But it goes beyond that. This fighter needs to pull targeting data from drones, other fighters, and big airborne early warning planes. Basically, it's designed to be the quarterback in a networked battle. They are diving deep into integrated sensor research, working on network-centered battlefield management, and developing high-resolution infrared imaging. The aircraft will probably get conformal radar antennas built right into the airframe, plus electronic support measures and countermeasures. Defense Minister Taro Kono has been pretty clear about expectations. The jet needs serious network capabilities and should carry more missiles than the F-35. When aviators think about it, these specs line up perfectly with what the YF-23 was designed for. Both aircraft prioritize stealth and long-range combat over old-school dogfighting skills. In modern air warfare, having better sensors and flying faster matters way more than being able to turn tight circles. The F-3 is designed to have serious technology. There are rumors about stealth shaping, radar-absorbent materials, and digital fly-by-light control systems, which are the cutting edge of fighter aircraft design. A lot of what they have learned will come from the X-2 Shinshin, Japan's experimental stealth demonstrator that's been their testing ground for new ideas. The X-2 gave them hands-on experience with composite structures, thrust vectoring paddles, and tapered wings designed for agility. Japan's also been studying how to hide weapons inside the aircraft to keep that radar signature low, plus they are looking at thrust deflection nozzles to boost maneuverability. Here is where it gets interesting. The original YF-23 didn't have thrust vectoring and relied purely on its airframe design for maneuvering. The F-3 might combine both approaches, using smart aerodynamic shaping and thrust control to get the best of both worlds. For the engine, Japan's IHI Corporation has been working on the XF-9 specifically for this project. They started testing engine components back in 2015, with prototypes planned through 2018. The XF-9 is designed for a high thrust-to-weight ratio and should pack more punch than the XF-5 they used in the X-2. Range is a big deal for Japan. The F-3s are expected to be bigger than the F-23 because they need space for more fuel and weapons. Aviation reporter Bradley Perrett started calling the concept Godzilla because of how large it's supposed to be. That focus on range shows what made the YF-23 attractive back in the day. What would a Japanese YF-23 actually look like? Japan is not building an actual YF-23, but it is worth thinking about how Northrop's design ideas influence the F-3. The shape would be key: diamond or trapezoidal wings flowing smoothly into the fuselage, with every surface angled to send radar signals bouncing away rather than back to whoever's looking. The entire aircraft would follow one rule: be invisible first, handle everything else after. But there is a twist. The original YF-23 didn't use thrust vectoring nozzles. It relied on careful aerodynamic design and smart engine placement for control. Japan has been studying thrust deflection though, so they would probably blend both approaches. They would use Northrop's sleek stealth design combined with modern thrust control for situations where aerodynamics alone aren't enough. This wouldn't be built for close-in aerial combat. Instead, it would excel at spotting threats from far away, launching missiles at long range, and disappearing before the enemy even knows what happened. It would act as a long-range interceptor with exceptional stealth capabilities. This is all theoretical, of course. The YF-23 had this clever SERN system that was good at hiding engine heat. For any Japanese fighter, that same capability would be crucial because today's air defense systems are incredibly good at tracking heat signatures. Japan's been working on high-power microwave technology and advanced heat transfer systems to tackle exactly these problems. The F-3 could easily borrow cooling methods and exhaust shaping from the YF-23 to keep its heat signature low. Here is something interesting. The original YF-23 prototypes never actually carried their mission avionics. Northrop tested all that sensor equipment in labs on the ground and in other aircraft. But modern air combat is completely different. Today's fighters need to be information hubs that can talk to everything else in the battle. Japan's been planning for this from day one. Their F-3 concept builds in sensor fusion and data links right from the start. So if people imagine a Japanese version of the YF-23, it would have sensor capabilities that blow the original prototypes out of the water. Aviators are talking about systems that pull together data from radar, infrared search and track, and electronic support measures, then share all that information across the entire battlefield in real time. The original YF-23 was impressive for its time, but this hypothetical Japanese version would be operating in a completely networked environment where every piece of information gets shared instantly with allies. That's a huge leap from where fighter technology was in the 1980s and 90s. Here is where Japan's approach differs from what Northrop was thinking back then. Japan wants their F-3 to be highly maneuverable. That's why they tested thrust vectoring paddles on the X-2. But Northrop took the opposite route with the YF-23. They ditched thrust vectoring entirely to keep the weight down and focused on making the airframe as aerodynamically clean as possible. Japanese engineers will probably split the difference. They might combine smart aerodynamic design with some thrust vectoring to handle high angle of attack situations. But if Japan really wants a long-range interceptor that can hit targets way out over the Pacific, then the YF-23's focus on range and fuel efficiency still makes a lot of sense. There is another big reason why Japan won't just build a modernized YF-23. They want to keep the profits at home and make sure their aerospace industry stays sharp. Licensing a foreign design doesn't accomplish that goal. Even though nobody's building another YF-23, its story offers some useful lessons for Japan and anyone else designing next-generation fighters. The lessons boil down to priorities, presentation, and partnerships. Northrop skipped thrust vectoring to save weight, but that hurt their agility scores. Modern fighters don't have to make that same trade-off. Engineers can have both aerodynamic shaping and thrust vectoring if they design it right. Japan's F-3 program is looking at thrust deflection nozzles and integrated weapons bays. The key is balancing these technologies instead of going all in on just one approach. Here is something people don't talk about much. Northrop lost partly because they were terrible at marketing. Lockheed knew how to put on a show and impress the people making decisions. Japan's fighter program is going to need public and political support for decades. Sure, demonstrators like the X-2 and cool concept art get people excited, but engineers need steady communication about what you're accomplishing and why it matters. Northrop's YF-23 would have been expensive to build for just one customer. Look what happened to the F-22. They only made 187 of them before shutting down production. Japan's program isn't just about getting a new fighter. They want to keep their aerospace industry healthy and maybe even sell these aircraft to other countries. That means controlling costs and building domestic supply chains. The YF-23's canceled production shows how fast programs can die if they don't have a solid industrial foundation. Northrop had brilliant engineers, but they kept to themselves too much, and that hurt their chances. Japan's F-3 will only work if they mix their talent with expertise from other countries. The GCAP deal with the United Kingdom and Italy shows they understand this. Building advanced fighters is a global effort now. Sharing costs and technology makes the whole thing less risky. Japan's F-3 and GCAP projects are moving forward. They are planning for a prototype in the next few years and want it in service by the mid-30s. Whether it succeeds will depend on how well they balance stealth, range, agility, sensor integration, and cost. The YF-23 was an impressive aircraft that pushed what was possible with stealth and speed technology. It proved that engineers can design fighters around completely different priorities, and that sometimes even the better design doesn't win for reasons that have nothing to do with engineering. Japan's fighter program won't copy the YF-23, but aviators can see its influence in what they are planning. That focus on stealth, range, and trying new approaches, that's still driving the next generation of fighters being developed today. When people see headlines talking about a Japanese YF-23, it is important to remember the real story is more compelling than the hype. Japan is not rebuilding an old American design. They're creating their path forward, taking lessons from past projects like the YF-23 and applying them to their current needs. What they end up building will probably be a serious piece of military hardware, designed specifically for Japan's strategic situation and incorporating lessons from both the YF-22 and the YF-23 programs. For people who love aviation, the YF-23 will always represent what could have been. But more than that, it shows how innovation keeps moving forward, even when specific projects don't make it to production. The ideas live on and shape what comes next. Forget everything you thought you knew about tanks. While the powerful M112 Abrams and the formidable KF-51 Panther grab the spotlight with their firepower, Japan's Type 10 is quietly changing the game. Sleek, fast, and adaptable, this tank is built for more than just combat. It's designed for precision and speed. Whether it's taking on enemy tanks, making quick strikes, or handling the most challenging battle scenarios, the Type 10 excels. But what makes this Japanese beast stand out from the rest? Could it be more formidable than the United States and Germany's battle tanks? Join us as we explore all of the intriguing reasons why this Japanese tank will change everything. 70 years ago, on July 5, 1943, the Battle of Kursk began, becoming one of the deadliest tank battles in history. The skies over the Russian city of Kursk exploded with firepower as German tanks, including the fearsome Tigers and massive Ferdinand tank destroyers, charged into battle. These German tanks were deadly machines, built to crush their enemies with overwhelming force. One German tank commander even managed to destroy 22 Soviet tanks in under an hour, demonstrating the power of these war machines. But the Soviets didn't back down. With over 6,000 heavy tanks of their own, the Russian forces fought with determination. They used close-quarters tactics, planting mines under the German tanks to disable them. Despite the Germans' powerful tanks, the Russians' fierce resistance and dangerous strategies turned the tide of the battle. After 8 intense days, the German tanks were worn down and unable to continue their attack. The Soviet counteroffensives then crushed the German forces, delivering a crushing blow to their ability to fight on the Eastern Front. The Battle of Kursk proved just how deadly tanks can be, changing the course of the war and altering who holds the upper hand. Tanks, with their armored shells and powerful guns, have long been feared on the battlefield. Whether it's the terrifying German Tigers or the Soviet T-34s, these machines have always been designed for sheer destruction. Their firepower and strength make them some of the most lethal weapons ever built for war. In modern times, tanks remain just as deadly. Though air power has dominated modern warfare, the presence of these massive machines continues to intimidate adversaries. The US and Germany have long led the way in tank development, but now Japan has joined this exclusive group. With the introduction of its own advanced Type 10 tank, Japan might just have secured its place among the nations that wield some of the world's most potent and formidable military machines. The development of the Type 10 main battle tank began in 2002 by Japan's Technical Research and Development Institute. By 2006, a prototype was ready, and testing took place in 2007 and 2008. After completing further trials on shooting and networking, TRDI finished the development in 2009 and started full production in 2010. The Type 10 MBT was designed to replace Japan's older Type 74 and Type 90 tanks. It features significant upgrades in areas like mobility, protection, firepower, and overall performance, making it one of the world's top 10 battle tanks. Japan's journey with modern tanks began in the 1960s when it became clear that the older Type 61 wouldn't be able to keep up with newer Soviet designs like the T-62. To address this, Mitsubishi Heavy Industries began developing a new tank, which became the Type 74. The first prototype was completed in 1969, and the tank entered full production by 1975. The Type 74 was designed using ideas from Western tanks, placing it in the same category as the M60 Patton and the Leopard 1. However, by the time the tank entered service in the 1980s, newer and more advanced Western designs were already available, leaving the Type 74 outdated even before it fully joined the Army. Production ended in 1989, and only about 890 units were built. The Japanese Ground Self-Defense Force was the only operator of this tank, as Japanese laws prohibited military exports. The Type 74 design included a cast turret similar to that of the French AMX-30. It was armed with a 105mm rifled gun, which was the British L7 gun made under license in Japan. Early prototypes of the Type 74 had an autoloader, but it was removed due to complexity and cost. The tank was initially equipped with high explosive rounds, but later upgraded to more advanced armor-piercing rounds. It carried 55 rounds for the main gun, with 14 rounds stored in the turret and the rest in the hull. One of the exceptional features of the Type 74 was its fire control system, which was revolutionary at the time. It was the first tank in the world to include a computer for ballistic calculations and a laser rangefinder. Later versions of the tank were upgraded with infrared imagers, which made the tank even more effective in combat. The secondary weapons included a 7.62 coaxial machine gun and a 12.7mm machine gun mounted on the roof. The Type 74 also featured an all-welded hull, NBC protection, also known as nuclear, biological, and chemical protection, and an automatic fire suppression system. It had a crew of 4, a commander, gunner, loader, and driver. Over the years, the Type 74 became outdated, and Japan moved forward with the development of the Type 10, which is now one of the most advanced tanks on the global stage. The Type 10 is an embodiment of Japan's military innovation and a formidable force in modern armored warfare, joining a select group of nations, including the US and Germany, with access to such powerful battle tanks. With its cutting-edge technology, high maneuverability, and superior performance, the Type 10 is now a key player in Japan's defense strategy, marking a new chapter in the evolution of military tanks. The Type 10 MBT is equipped with a sophisticated turret featuring an automatic loading system. This advanced system allows the turret to rotate 360 degrees, ensuring it can track and target enemy forces from any direction. The tank is armed with a powerful 120mm L44 smoothbore gun, which is manufactured by Japan Steelworks under license. This gun offers immense firepower and precision, making it a formidable weapon on the battlefield. The 120mm L44 smoothbore gun is capable of using all standard NATO 120mm rounds, as well as those specifically designed for the Japanese Ground Self-Defense Force. However, the most intriguing feature is the Type 10's ability to fire the Type 10 APFSDS, or armor-piercing fin-stabilized discarding sabot round. This unique round is specially designed for the Type 10 and can only be fired by this tank's gun, giving it a significant edge in terms of firepower over its competitors. One of the key innovations in the Type 10 is the auto-loading mechanism, which eliminates the need for a dedicated crew member to load the gun. As a result, the Type 10 operates with a smaller crew of just 3, the commander and gunner in the turret, and the driver in the hull. This reduction in crew size contributes to the tank's efficiency and overall performance, while also minimizing the risk to personnel. The auto-loading mechanism is housed in the rear section of the turret, giving the tank its distinctive appearance. The gun is aimed with the help of a set of advanced sighting arrays that provide 360-degree visibility, both day and night. These sighting systems offer exceptional target identification and tracking capabilities, even in low-visibility conditions. Additionally, the barrel of the gun is fitted with a muzzle reference sensor located to the right of the muzzle. This sensor plays a crucial role by detecting any slight deformation or warp in the barrel, ensuring the gun maintains optimal accuracy at all times. However, the most important question is how effective and formidable it really is when compared to battle tanks from other developed nations. So how does the Type 10 compare to the United States M1A2 Abrams and the German Kf-51? The M1A2 Abrams is one of the strongest and most respected tanks in the world, used by the U.S. Army. Weighing about 68 tons, it combines powerful armor, heavy firepower, and impressive speed for its size. Its main weapon is a 120mm smoothbore gun, capable of firing various types of ammunition. This allows it to destroy heavily armored targets with ease and gives it a big advantage in battle. The tank is operated by a crew of 4 people, a commander, gunner, loader, and driver. Inside, it is packed with advanced technology like thermal imaging, computerized fire control, and reactive armor, which helps it survive enemy attacks. With these features, the M1A2 is not just tough, it's smart too, making it a fearsome opponent on any battlefield. The M1A2 was officially approved for production in 1990 as an upgraded version of the M1A1 Abrams. At first glance, the two tanks looked pretty similar, but the M1A2 introduced major improvements on the inside. On the outside, the most significant changes include a redesigned commander's weapon station and a new commander's independent thermal viewer, located near the loader's hatch. These upgrades help the tank become even more powerful and effective. One of the most impressive innovations inside the M1A2 is the Inter-Vehicle Information System, also known as IVIS. This smart system lets different vehicles share information with each other instantly and automatically. Thanks to an onboard navigation system, commanders can track their units' locations in real time without distracting the crews. IVIS also lets soldiers quickly mark enemy positions, send artillery requests, and share mission orders. Everything is fast, automatic, and smooth, helping the whole team stay connected in the heat of battle. To keep this valuable information secure, all IVIS data is transmitted through a secure SINC GARS radio system, making it difficult for enemies to intercept. The M1A2 also improves on the hunter-killer method first used by Germany's Leopard 2 tank. With the new commander's independent thermal viewer, the tank commander can now search for targets at any time, day or night, and even through smoke or bad weather, while the gunner focuses on firing. This speeds up the tank's ability to find and destroy enemies before they even know what's happening. Besides IVIS and CITV, the M1A2 also receives several electrical upgrades. Power is now distributed through multiple paths within the tank, so if one part is damaged, electricity can still reach critical systems via backup routes. The driver's controls were updated with a new digital display, and the gunner's primary sight was stabilized better, meaning more accurate shots even when the tank is moving. In 1995, the U.S. Army introduced another improvement, known as the M1A2 SCPOR System Enhancement Package. This upgrade aimed to bring all M1 and M1A2 tanks up to the same modern standard. Major changes included a new auxiliary power unit placed under the armor, and an air conditioning system to keep the crew cool during long missions. Inside the tank, upgrades included a color display for the IVIS system, a full-size keyboard, digital maps, graphic generation tools, and even voice recognition. The gunner's sight, the intercom, and radio systems were also improved to make communication faster and clearer during fights. Production of brand new M1A2s stopped after 627 tanks were built. However, the Army began upgrading 547 older M1s to the new M1A2 SCP standard, which involved rebuilding the turret almost completely. Existing M1A2 tanks were also retrofitted to match the SCP upgrades, ensuring all U.S. Army tanks stayed deadly, smart, and ready for modern combat. Comparing the capabilities of the American M1A2 Abrams and Japan's Type 10 is quite interesting. Both are fierce in their own ways, but they were built with very different ideas in mind. One is a massive heavyweight made to crush anything in its path. The other is a fast and smart fighter made to dance around enemies with speed and technology. Let's dive into what makes these two tanks so unique. First, let's talk about size and weight. The M1A2 Abrams is a giant, tipping the scales at about 68 tons. It's built like a fortress on tracks, able to take a beating and keep moving. On the other hand, the Type 10 is much lighter, weighing around 44 tons. Japan designed it to be fast and agile, perfect for the country's many mountains and tight spaces. While the Abrams is like a heavyweight boxer, The Type 10 is more like a quick and clever martial artist. Both tanks pack serious firepower. The Abrams is armed with a 120mm smoothbore gun that can fire a variety of NATO rounds. This gives it great flexibility against different types of targets, from enemy tanks to bunkers. The Type 10 also uses a 120mm smoothbore gun, built specially by Japan Steelworks. It can fire regular NATO rounds too, but it also has a special trick up its sleeve: the Type 10A PFS-DS round, a unique armor-piercing shell designed for maximum punch against modern armor. The crews inside these tanks are a little different too. The M1A2 Abrams needs 4 soldiers to operate: a commander, a gunner, a loader, and a driver. In contrast, the Type 10 only needs 3 because it has an automatic loading system that handles the job of loading shells into the gun. This not only saves space inside the tank, but also makes it a little lighter and faster. Technology is where both tanks really shine. The M1A2 Abrams is loaded with high-end tech, including thermal imaging to spot enemies day or night, a commander's independent thermal viewer that lets the commander find and mark targets even while the gunner is firing, and the smart inter-vehicle information system, which allows tanks to talk to each other and share battlefield information instantly. The Type 10, while smaller, is no slouch in the technology department either. It has full day and night sights, a muzzle reference sensor that checks if the barrel has warp during battle, and a smart communication system that lets it share data with other units in real time. Plus, the Type 10 can actually adjust its suspension to lower or raise itself, giving it better firing angles or making it harder to hit. Armor is another big difference. The M1A2 Abrams is like a tank in the truest sense. It uses thick composite and reactive armor to survive direct hits. Meanwhile, the Type 10 uses modular armor, which means armor plates can be swapped out depending on the mission. If speed is needed, it can go lighter. If protection is needed, it can bulk up. Eventually, the choice between these two tanks comes down to what one needs on the battlefield. The M1A2 Abrams is a fearsome force, made to dominate in heavy, head-on battles where firepower and protection matter most. The Type 10 is made for fast, smart warfare, where quick moves, good communication, and flexibility win the day. But how do both of them compare to the renowned and formidable KF-51? The defense world has been buzzing about the KF-51 Panther tank, and it's easy to see why. At the heart of its power is a brand new gun called the Future Gun System. It's not just a new paint job. This 130mm gun is a game changer. It's bigger than the usual 120mm guns and fires faster, reaching targets up to 3,500 meters away, about 1,000 meters farther than most tanks. This gives the Panther a considerable advantage. It can hit enemies before they can even fire back. The Future Gun System isn't just strong, it's smart. It can fire regular armor-piercing and explosive rounds, but it also has special programmable ammo that can explode in the air, hitting drones and hidden soldiers. However, it does carry fewer rounds than other tanks. Luckily, the Panther's autoloader system makes up for this. While many Russian tanks have utilized autoloaders for years, this is a new development for German tanks. It allows faster shooting, 2 rounds every 3 seconds, and gives the tank a lower, harder-to-spot profile. Inside, the Panther has 4 seats instead of the usual 3. The extra seat can be used by a drone operator or a company commander. And the Panther isn't just about heavy guns, it's loaded with extra gadgets too. It has a 7.62mm machine gun mounted on top, called the N, that can shoot almost straight up, mainly to defend against enemy drones. It also carries 4 Israeli Hero 120 loitering munitions, which are flying bombs that can circle the sky for an hour before striking. Defense doesn't stop there. The Panther has a top attack protection system to guard against missiles attacking from above. If that fails, there's the rapid obscuring system, which blasts special smoke to block enemy sensors. And if all else fails, the Panther is wrapped in explosive reactive armor that punches back at incoming weapons. But the Panther is not just muscle, it's brains too. Thanks to NATO's new tech rules, it's designed to easily accept new upgrades. It can send live info across the battlefield, acting like a scout and a fighter all at once. Using small drones, the Panther can spy far ahead without putting itself in danger. For all this gear, one might think the Panther would be slow. Not at all. It weighs just 59 tons, lighter than the 70-ton M1 Abrams, and its 1,500 horsepower engine gives it a power-to-weight ratio of 25. This means it can climb steep hills, cross trenches, ford deep water, and still hit speeds of 70 kilometers per hour. It can also travel over 500 kilometers on a single tank of gas. When compared to tanks like America's M1 Abrams and Russia's T-14 Armata, the Panther stands out. The M1 Abrams is powerful but heavier and less nimble. The T-14 has advanced ideas but has struggled with real-world use. The Panther, combining firepower, protection, speed, and smart tech, looks to be the best of the three. The YF-23 was a failure. Many believe this revolutionary stealth fighter was lost to history after losing the U.S. Air Force contract to the F-22 Raptor. But now, decades later, Japan is bringing it back, with cutting-edge upgrades that could shift the balance of power in the skies. As tensions intensify in the Indo-Pacific, Japan is depending on the mind-blowing capabilities of the revived new YF-23 to deter the intensifying Russian and Chinese threats. But how does this restored combatant compare with contemporary opponents? And why is its comeback creating shockwaves within the international defense community? Join us as we unlock the secrets of Japan's $500 million YF-23 supersonic plane. Few aircraft in the world of military aviation have possessed as much charisma for airplane enthusiasts as the YF-23 Black Widow II. A marvel of stealth design, speed, and high-altitude aerodynamics, it was the pinnacle of American air superiority for a while. Yet due to its groundbreaking innovations, the YF-23 lost out to the YF-22 in the early 1990s, and its place in history remains only as an engineering masterpiece that never quite lived up to what it could have been. The YF-23 had for years been a relic, and almost was of history. But in a dramatic reversal, Japan resurrected this mythical plane, this time equipped with the latest cutting-edge technologies capable of reshaping the very face of air warfare. The new F-23J has next-generation stealth technology, autonomous battle systems fueled by artificial intelligence, and hypersonic speed, placing Japan in the world's arms radar. It was in the late 80s that the U.S. Air Force started creating a new air superiority fighter to replace the outdated F-15 Eagle and maintain American air supremacy. This led to the Advanced Tactical Fighter Program, which was a high-profile contest between two of the most powerful aerospace giants, Lockheed Martin and Northrop Grumman. This was the contest to select the next-generation air dominance fighter. Lockheed Martin unveiled the YF-22 and Northrop Grumman unveiled the YF-23, an aeroplane most aeronautics professionals believed mastered in its era. Northrop Grumman also worked with McDonnell Douglas in creating the YF-23, a fighter plane that most see as futuristic. In its design, compared to other ordinary fighter planes, the YF-23 possessed a slender, diamond-shaped airframe, greatly suppressing its radar cross-section and allowing it to approach invisibility before enemy radar screens. The airplane's V-shaped tail made all vertical stabilizers unnecessary, hence increasing its ability to hide itself. But what actually set the YF-23 apart was its super cruise capability and speed. Equipped with two General Electric YFone 120 or Pratt & Whitney YFone 119 engines, the aircraft could cruise supersonically without the use of afterburners. The ability gave the aircraft a big advantage over existing fighters, since afterburners have a tendency to greatly increase infrared visibility, making aircraft more vulnerable to enemy tracking. The YF-23 Black Widow II was an engineering masterpiece with a revolutionary, stealthy, high-speed, and aerodynamic design. Its V-tail and diamond-shaped fuselage radically reduced its radar cross-section, and it was among the stealthiest fighter jets ever built. Though the YF-23's greatest asset was its ability to strike unseen from long distances, it also featured super cruise, where it could sustain supersonic flight without afterburners. Even though these were its advantages, the U.S. Air Force ultimately chose the YF-22, which went on to become the F-22 Raptor. The basis for making this choice included a number of factors: The YF-22 had superior dogfighting performance that the Air Force believed would play a significant role in future air combat. Lockheed Martin also proposed mass production of its plane at reduced costs and less complicated procedures. Therefore, the YF-23, faster, stealthier, and more advanced, was relegated to the back burner forever. For generations, the YF-23 became a historical footnote, but with shifting world politics and advances in technology, Japan revived this once-abandoned marvel, this time with cutting-edge updates that could potentially change air dominance. Japan's decision to reactivate the YF-23 is not an accident. The Indo-Pacific area has become a geopolitical tinderbox, with the tensions between the world powers heightened. Japan had been relying on U.S. military protection for decades under their security agreement umbrella. However, China and Russia's recent advancements in the military have prompted Japan to rethink its traditional dependence on foreign allies. The constant missile tests of North Korea and the assertive territorial claims of China in the East China Sea have left Japan vulnerable to potential aerial attacks. China's Chengdu J-20 and Russia's Su-57 in particular have left Japan's defense establishment worried, introducing a treacherous angle to air superiority in the region. In recognizing the urgency of the situation, Japan has begun down a very aggressive road towards establishing its own state-of-the-art fighter plane program. Reactivation of the YF-23 is a cautious strategic move to bypass a decades-long development program through the development of an existing airframe that has already been proven. Instead of developing an all-new airframe from scratch, Japan is building its sixth-generation fighter, dubbed the F-23J now, from the breakthrough design of the YF-23. It allows Japan to accelerate its technological advancements and narrow the capability gap between China, Russia, and Japan's current technologies. For decades, it seemed as if the YF-23 was only going to amount to something out of historical memory. Not anymore. With Japan under pressure from escalating international tensions and taking note of an opportunity to bring this lost work back to life. The F-23J is more than just a revival of the YF-23. Japan has completely overhauled the aircraft, and it is now one of the world's most technologically advanced fighters. The foundation of the F-23J is an advanced stealth system that is ahead of anything ever made before. The YF-23's original radar-absorbing materials are upgraded with plasma-based stealth technology, a system that deforms electromagnetic waves to drastically reduce the aircraft's radar signature. In addition, the aircraft's composite materials and electromagnetic wave absorbers make it practically invisible to radar and infrared detection systems. The most impressive feature of the F-23J is probably its power plant. Japan's IHI Corporation has developed a next-generation XF-91 low-bypass turbofan engine, which can produce up to 44,000 pounds of thrust. This allows the F-23J to achieve supercruise speeds, sustain supersonic flight without afterburners, while greatly reducing its infrared signature. During flight tests, the engine has demonstrated moments of hypersonic speed above Mach 5, so the F-23J is one of the fastest fighter planes ever created. To supplement its unadulterated speed, Japan has endowed the F-23J flight systems with artificial intelligence. Onboard computer programs also support the pilot in threat analysis, automatically identifying enemy planes and projecting flight paths in real time. Autonomous dogfighting is also available in the F-23J, with AI dynamically recalculating flight vectors in a matter of microseconds after the identification of threats. The cockpit also contains voice control, enabling pilots to operate primary functions without needing to use their hands, a function that can be highly beneficial in high-intensity combat situations. Yet another groundbreaking feature of the F-23J is its loyal wingman integration of unmanned aerial vehicles or drones. The fighter will fly alongside formations of autonomous drones that can be used as missile launch platforms, recce vehicles, or electronic warfare assets. The drones are instrumented as force multipliers to augment the combat capability of the fighter with minimal risk to human lives. The F-23J's mid-air drone control capability is a quantum leap in autonomous warfare. Japan's decision to bring the YF-23 back to life isn't sentimental. It's a matter of survival. Japan has relied for decades on the US, Japan's security alliance, for its security. China's abrupt militarization, Russia's and North Korea's, compelled Japan to rethink its reliance on US defense. China's J-20 Mighty Dragon, Russia's Su-57 Felon, and North Korea's missile technology have put Japan at risk of potential aerial assault. Japan's current F-15J fleet, while potent, is rapidly aging. Even the F-35 Lightning II, which Japan has purchased from the US, is basically a multi-role fighter, not a specialized air superiority plane. Recognizing the urgent need for a homegrown next-generation fighter, Japan began the FX program, a multi-billion-dollar program to develop a sixth-generation aircraft by the 2030s. Rather than start over, Japan perceived value in the YF-23's pioneering design. Through the use of a proven vehicle as a basis, Japan would be able to speed up development, be economical, and install next-generation tech into a years-ahead-of-time aircraft already. The ultimate product? The F-23J, a sixth-generation fighter that will dominate the skies of tomorrow. The new technologies added to the F-20J make it the jack-of-all-trades fighter of modern air-to-air combat. Its most advanced feature may be in stealth, which has been taken to unprecedented levels. While the original YF-23 was difficult to locate in the first place, the F-23J employs plasma-based stealth technology that warps electromagnetic waves to absorb and deflect radar waves. This innovation renders it almost invisible, even to the most sophisticated radar systems. In addition to this, Japan's quantum radar, along with Mitsubishi Electric, allows the F-23J to detect the stealth fighter jets, such as the J-20 and Su-57, eradicating their greatest advantage and leaving Japan in the premier position of air superiority. Aside from stealth capability, the propulsion system of the F-23J makes it stand out from its predecessors and competitors. Japan's IHI Corporation has developed the advanced XF91 turbofan engine, which allows the aircraft to cruise at supercruise velocities above Mach 2.5, far beyond the capability of any F-22 Raptor. Record-breaking bursts of hypersonic speed above Mach 5 have been achieved in flight tests, and the F-23J may be the fastest fighter plane ever conceived. The combination of speed and stealth ensures the F-23J can enter and leave combat at will, enjoying a tactical upper hand in any fight. The incorporation of artificial intelligence places the battle performance of the F-23J on an even greater level. With its flight system managed by AI, the jet is able to dogfight automatically, using real-time analyzed data to predict adversary movement and alter flight paths accordingly. This not only enhances pilot performance, but also reduces response time on high-threat missions. The AI-powered system is designed to assess danger in the blink of an eye, launch countermeasures independently without the intervention of a human entity, and even engage coalition forces in real-time conversation, making the F-23J a smart and reactive warfighter. The second innovation of the F-23J is the integration of its loyal wingman drone feature, which allows the fighter to command an armada of drones AI-capable. The drones serve as carriers of missiles for faraway combat, reconnaissance vessels for instantaneous battlefield intel gathering, and electronic warfare specialists with jamming capabilities on the enemy's radar. By engaging these unmanned aircraft, the F-23J is a more effective instrument of war and reduces the risk to human pilots. The system turns the aircraft into something greater than a fighter aircraft. It is a force multiplier with the ability to control the air battle like never before, with unprecedented accuracy, acumen, and firepower. The fighter jet capabilities put it on par with the world's leading fighter planes. Compared to America's F-22 Raptor, the F-23J outshines its ancestor in stealth capabilities as well as in speed. Whereas the F-22 enjoys a high agility and close air combat capability, the F-23J, with its emphasis on long-distance combat and associated drone system, is far more versatile. Where the F-35 Lightning II is essentially an air-to-ground, multi-role combat aircraft, the F-23J is specifically an air supremacy fighter designed to dominate the airspace. To counter China's J-20 Mighty Dragon, the F-23J is the big threat. The J-20's strongest suit is its long-range strike capability, But the F-23J's quantum radar system, a next-generation system capable of detecting stealth fighters, renders the J-20's stealth capability irrelevant. The F-23J also leaves Russia's Su-57 Felon in its rear-view mirror with respect to speed and electronic warfare capabilities. Coupled with hypersonic propulsion and AI-powered combat systems, the F-23J could even potentially take out enemy fighters before they even knew it was coming. The F-23J has made waves within the global defense community. For decades, China has regarded itself as the dominant air power in the Indo-Pacific and has been concerned about increasing military power of Japan. Stealth capabilities and extended range of the F-23J pose an immediate threat to China's J-20s and may negate Beijing's regional strategic advantage. Russia has also noticed, with military analysts speculating that the F-23J might outclass the Su-57 and push Moscow to fast-track development of its own sixth-generation fighter. Even Japan's closest allies reacted in ambivalence. The United States, while it backs Japan's military modernization, is wary of the F-23J's potential to rival its own future air superiority programs. South Korea and Australia, however, are considering collaborative partnerships with Japan to co-develop next-generation fighter technologies. Japan's defense ministry has grand plans for the F-23J, and the first prototype is expected to take its first flight by 2027. The F-23J is slated to go into production in full by the early 2030s, with at least 100 units expected to be deployed. Japan is developing a carrier-based variant of the F-23J to equip future aircraft carriers in the future. In addition, the country is working on a hypersonic bomber that will be using much of the technology created by the F-23J. With the F-23J as its top aircraft, Japan is not just enhancing its own defense, but emerging as a world aerospace technology leader. Export negotiations for possible export orders already exist, and countries like Australia and the United Kingdom are already showing interest in buying the planes. What was junk is now Japan's finest war treasure. The F-23J, Phoenix risen from the ashes of the YF-23, will offer air superiority revolutionary in hypersonic speed, computer war, and unmatched stealth. The revival of the YF-23 as the F-23J is a jewel in the history of military aviation. The cutting-edge fighter, once branded as a failure, is staging a comeback in dramatic style, equipped with the best technology and a new mission to safeguard Japan's airspace. Unmatched stealth, hypersonic power, and AI combat systems put the F-23J poised to revolutionize the balance of power in the Indo-Pacific region in the world. The YF-23's main radar-absorbent materials were supplemented with plasma-based stealth technology, a new platform that reflects electromagnetic waves to substantially cut the airplane's radar footprint. The aircraft's electromagnetic wave absorbers and composite materials make the plane essentially radar invisible, as well as infrared invisible. If the fighter jet is a success, it will not be long before Japan is a player in the ranks of world super defense exporters, joining Australia and the UK most likely to modernize their own forces with advanced Japanese fighter jets. To that extent, the F-23J is less a weapon than a statement that Japan is setting itself up as one of the world's leading defense forces. Apart from the technical marvel of the airfighter, its revival has behemoth's psychological effects on global defense policy. War is guns, but also mind. And in reviving the YF-23 in a totally different incarnation, Japan has declared a paradigm shift in its defense policy. This move forces competitors like China and Russia to recalculate their own mathematics on the military, because the rebirth of an airplane that was considered too advanced when it flew decades ago leaves one wondering. Military planners must redo their strategic calculus now that they understand Japan is no longer merely playing defense, but is actively building its way toward regional air superiority. The introduction of the F-23J to the Indo-Pacific rebalances power and causes competitors to redeploy resources in order to combat this nascent threat. Slowness costs as much as defeat in this war, and Japan's move to resurrect the YF-23 is a strategic maneuver to make competitors hold back. The F-23J is far more than a replica of the YF-23. Japan has redesigned it from scratch, and it is among the world's top fighters. The heart of the F-23J is an entirely new stealth system that outperforms anything of the last generation. The YF-23's early radar-absorbent materials have now been replaced by plasma-based stealth technology, a newer system that deflects electromagnetic waves off to decrease the radar signature of the aircraft dramatically. The electromagnetic wave absorbers and the composite materials used in the aircraft also make it essentially invisible to radar and infrared detection systems. This shift is more than simple perception. It suggests a dramatic shift in Japanese military policy. Japan's self-defense forces for decades had been structured around an interception-centered air force, designed primarily to defend against threats approaching and not to project force. The coming of the F-23J, however, signals that Japan no longer contentedly protects only its airspace. Instead, it is turning towards a preemptive policy in which it can strike threats even before they enter Japan's borders. Apart from being a huge defense development, the F-23J is also a massive economic and industrial success for Japan. Producing a next-generation fighter aircraft has been about protecting one's nation. It's also about world economic and technological domination. With billions of dollars already invested in the project, Japan's defense industry is experiencing a historic boom, with thousands of high-tech positions created and innovation in aerospace engineering, avionics, and weaponry. Most importantly, this program is part of a broader effort to wean Japan away from American defense technology so that future military capabilities will remain under Japanese control. After being relegated to the pages of history, the YF-23 has been resurrected as the F-23J, one of the most advanced fighter planes in the world. With next-generation stealth technology, hypersonic capabilities, and AI warfare, Japan is making a statement. It will not be left behind in the race for arms. But Japan's rise to air dominance won't be easy. While China and Russia are barreling toward their own sixth-generation fighter projects, the skies of the Indo-Pacific are becoming increasingly contested on a scale unseen before. Will the F-23J forever solidify Japan's position as an air power giant, or has it just paved the way for the next great aerial armaments race? Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.